Circular motion part on Friday. That was a quick one. Today, as you see, we're doing linear motion in 1 and 2 dimensions. So it's essentially the same as we did last year, you did last year, but then we go into 2 dimensions, which makes it a little bit different. We have projectile motion tomorrow and relative motion on Wednesday. Those are the 4 lessons that we have in our unit. And then we're done. This part, and then you guys have a test. So we have some freedom this week to speed up and slow down. So I want to make sure that we're going the quicker pace on things you understand, and if we have to dial it back, slow it down, then we can do that too because we have time. So just make sure you guys ask the questions that you need, because theory and term-wise, everything we're doing this week, you did last year. So there really isn't anything new. I might ask you questions that make you think a bit harder, theory-wise, but there isn't, and then the math will be harder because it will be in 2 dimensions, but the rest of it's all the same. So, yeah, that's kind of where we're at. Are you guys okay with this unit? You excited about it? Or at least not cringing, maybe as much as you might have been with light? All right, so here's some words. Take a look at the list of words. That's grade 11 right there. Yeah. Yep. Take a moment, talk to your elbow partner if you have one, and talk it out. Go through the list in your head, or it's easier if you talk to somebody about what's on the list. If you are sitting by yourself, just talk to the people around you and kind of go through each of the terms there. You can check it off in your head mentally. You can write it down on a piece of paper so you remember it. And we'll only go over the ones that you guys don't know. If you don't know all of them, which is fine, then we can go through all of them. But I don't want to spend time on things that you might find boring when we can do other stuff. Okay, so give you guys 5 minutes to go through the list, okay? Olivia, if you have any questions, you can ask me.
And the other thing, all I remember is I don't remember the difference.
So average salary.
Give me, let's name 5 scalars that can't also be vectors if you just tack a direction on the end. What are 5 scalar quantities that you know off the top of your head? Ethan?
Time.
Time is 1, good. Andre?
Weight.
Weight is not 1, no.
Mass is.
Pardon?
Mass?
Mass is, yeah. Brennan?
Height.
Height? No, because you can say up or down. Weight is a vector quantity because it's based on the force of gravity.
Yeah, I just realized that.
Yeah. So we got 2 so far.
I was 11.
You did a ton of them last year in physics. Yeah?
Speed?
If I had direction, that turns into velocity.
Yeah.
Yeah, so no. Doesn't fit my criteria. You're not wrong. It is scalar, but I'm looking for things that I can't just add north to it and make it a vector. You got mass and time so far.
Isn't distance a scalar quantity?
I can add, it is, but I can add north to it to make it displacement.
Right.
So I'm trying to avoid those.
Density?
Density is 1, yes. Come on. You guys know more than this. Jake?
Would volume be one?
Volume would be 1, yeah. And
Temperature?
temperature is definitely 1. We got 5. Anybody else want to say anything? Honey?
Energy?
Energy, which is measured in?
Joules.
Joules is 1, yeah. So you guys, that's fine. Ethan, you were just talking about this unit the grade 11s are finishing right now. What unit was that?
Electromagnetism.
Electromagnetism. How many of those do you know? Patty?
Like amperes.
Amperes.
I think it's called like coulombs.
Coulombs, yeah, for sure. Voltage, ohms. You guys know a lot of them. You just never think of it in that context, right? And vectors always have directions, so we always have to make sure we do our directions in square brackets. So I like my directions like this. North 15 degrees east. That's me and my training. You might like it as 15 degrees east of north, which is the same thing. Whatever method you choose is yours. Like you have to just be comfortable with it. Both mean the same thing up there. In my writing, when you read it, north is the axis that you're measuring the direction from, and then I'm going 15 degrees to the east, which is how I've always done it. If you do this one, it's the same thing. North is the axis you're doing it, and you're going east by 15 degrees. You have to read it in the reverse way. Again, your choice how you read them. On your test, you'll always see the first one. Are we okay with the next triplet here? Position, displacement, distance. Any questions with those? We're good? Okay. I also have a slide about it coming up, so I'll pick your brain when we go there. Are we okay with average speed? I don't know why I didn't put speed up here. Average speed and average velocity. Yeah, Andre?
What's the equation to find those again?
I will show you in 2 slides. Yeah. Which one is always greater, equal to, or greater than the other one? If you had to differentiate between the two. One is always equal to or greater than the other one. If you had to compare them. Jake?
Distance is always equal to or greater than displacement.
Yep, good. So in terms of average speed and average velocity, which one would always be equal to or greater? Average speed or average velocity? Andre?
Would it be speed?
It would be speed, yeah. Speed is based on distance traveled, right? So your average speed will always be equal to or greater than the average velocity. Our average velocity could be 0, but you've moved a lot, right? So it could be, or it could be negative. Average speed can never be negative. It's just based on how far you travel. Are we okay with the terms that have instantaneous in front of it? It's a great Scrabble word. Instantaneous, lots of letters there. Are we good with instantaneous speed, instantaneous acceleration?
Does that just mean what it is at a specific moment?
Yeah.
Okay.
Yep. Does the speedometer on your car measure average speed or instantaneous speed? So you drove to school, I know some of you drove to school today, you're right, you're looking at your speedometer. Is that your average speed of your trip to school or your instantaneous speed? Brennan?
Instantaneous speed.
It's your instantaneous speed, right? Because it's how fast you're going at that moment. That's important to know, not how long it took you, your distance divided by the time it took you to get here. That'd be lower than your instantaneous speed. Yeah.
Do you use a tangent line to find these on a graph? Or
Instantaneous, anytime, anything instantaneous, exactly, use a tangent.
is there like a way you could do it without a tangent line or no?
Like mathematically, no.
Okay.
No, you could. Yeah. No, there wouldn't be. Other, you have a speed gun. Which reminds me, I wanted to get a speed gun today. Forgot about that. And are we okay with average acceleration? I'm going to use the word acceleration. Just keep things easier. It's just one word instead of average acceleration. But I mean the same thing when I say acceleration. We don't deal with instantaneous acceleration in our class. We're not doing anything with graphs. You guys did graphs last year, right? So everything is strictly math-based this year and not graph-based. So we don't deal with the tangents or anything instantaneous. Are we okay with uniform motion and uniform acceleration? Maddie?
Could you just